Hey everybody, so we're here and we're ready to go over the midterm review sheet. If there's a question that you've gotten that you've done in class and you just want to skip to the next, just fast forward and find the question you're looking for. We're going to start with number one. Select all equations that are equivalent to 3x plus 6 divided by 2 equals 2 minus 6x plus 9. And what you want to do here is you want to make sure that you are looking at this equation and seeing how did this equation become this equation. And if that it breaks a rule of mathematics and it could not have done that, then those equations are not equivalent. So let's talk. If I What I like to do is I like to break it down and look at the left side of the equation and the right side of the equation. So I'm going to break this in half. If I look at the left side of the equations are different. It's missing the dividing by 2. If I look at the right side of the equations are the same. So let's see, we want to figure out what happened to this 2. In order to get rid of a 2 that is being divided, you would have to multiply this side of the equation by 2. And if you do that, you have to also multiply the other equation by 2, or the other side of the equation by 2. So this side is multiplied by 2 and the 2's cancel out. We're left with 3x plus 6. But if we multiply the right side, all of these values should have doubled. Because they're the same, that means equation A is not equivalent. This is not an option. Okay, let's erase and look at equation B. Equation B, again, I'm going to put that line down the middle. The line down the middle. The left side is not the same, but the right side is. Let's see what happened. So if I take a look at this, we have 3 over 2x plus 3. 3x plus 6 is gone. So let's see what happens. If I write 3x plus 6 over 2, what's happening here is that the 3x and the 6, they're both being divided by 2. So we also can write this as 3x over 2 plus 6 over 2. And when we look at it this way, 3 over 2, if you divide that, that's going to be a decimal. But if I divide 6 over 2, that's positive 3. So this here is the same as saying 3 over 2x, and then we simplify 6 divided by 2, and that's positive 3. So 3 over 2x plus 3 is the same thing on this side. All they did was simplify. They didn't add anything, they didn't subtract anything, they didn't multiply anything or divide. So this equation is equivalent. Let's look at option C. 3x plus 6 divided by 2 on the left, and then negative 6x minus 7 on the right. Actually, I'm going to look at C and D together because they're very similar. If I look at the left side of both equations, they're the same as what we started with. So the right side, something happened to it. Let's take a look what happened. If we simplify this side of the equation, we have to distribute this negative to the 6x, so that'll become minus 6x. Distribute that negative to the positive 9, minus 9. And if I bring down that 2 we start with, this is simplified to 2 minus 6x minus 9. Now what I can do is I can combine my like terms, which are 2 and negative 9. And when I combine those like terms, this will simplify to, this is the same as saying 2 minus 9, which is negative 7. And if I bring this at the beginning, negative 6x, I get negative 6x minus 7, which is what is here. So the option is C, but it's not negative 6x plus 11, so it's not D. Now, let's take a look at equation E. If I simplify this, we have this is simplified version of the right side, negative 6x minus 7. And on the original equation, I have 3x plus 6 over 2. If I look at this equation, how does the left differ? The left side, the dividing by 2 is missing. And on the right side, the whole equation is different. We have negative 12x minus 14, or the whole expression is different. So how did this become this? Well, remember, we said to get rid of that denominator of 2, or to cancel it out, you would have to multiply the left side of the equation by 2. And what you do to one side, you must do to the other. Multiply the right side of the equation by 2. This will cancel out, and we are left with 3x plus 6 is equal to, what is 2 times negative 6? That is negative 6x, so that's negative 12x. And then 2 times negative 7 is negative 14, which simplifies to negative 12x minus 14. If you look at these equations, they are identical now, so E is also an equivalent equation. Move on to number 2. In a basketball league, a sports facility charges a base fee of $20 per game, plus an additional charge per player. The total cost T for a team can be represented by the equation T equals 20 plus P times C, where P is the additional charge per player and C is the number of players on the team. What equation can be employed to determine the number of players on a team if we know the additional charge per player P and the total costs T? So this one you really want to remember and read in what are they looking for. They're not looking for P, they're not looking for T. What they want us to look for is what equation can determine the number of players on a team if we know the value of P and if we know the value of T. Well, let's think about and look back at the original question. What represents the number of players on the team? Well, if you look here, it says C is the number of players on the team. So that means we want an equation that solves for C. But also, something I notice is if I look at the all the multiple choice options, they all have C on the left side, which means we're probably trying to solve for C. So what we're going to do is we're going to take our original equation, T equals 20 plus P times C. And what we want to do is we want to solve for C. We want to make an equation to solve for C. So what we're going to do is we are going to use inverse operations. If I want to get C by itself, I notice the operations that are happening here is that there's multiplication happening between P times C, and there's also addition happening with the 20. So we have multiplication and addition. And we're going to use inverse operations. So we're going to work backwards. The first thing we're going to do is we're going to do the inverse of addition, and we're going to subtract. We want to subtract this 20 and get it away from that C. So subtract 20 to this side. What you do to one side, you must do to the other. Now we cannot combine T and negative 20 because we don't know the value of T. So this becomes on the left side, we have T minus 20 is equal to P times C. Or you could also just say PC. You don't have to put the letter. Now, we don't have any more addition. We just have multiplication. So to do the inverse of multiplication, we are going to divide. We want to get C by itself, so we want to divide that P out of this equation. You divide P to this side, you must do it to the other side. So now we're left with T minus 20 all divided by P is equal to C. So the equation for the number of players on the team is T minus 20 divided by P, which is this option right over here. Awesome. We're going to scroll down. We're going to go to number 3. So this is not a multiple choice question. These are options A, B, C, D, and E. Sorry, not options. These are questions, A, B, C, D, E, and E. We're going to start with A. A school sells adult tickets and student tickets for a play. It collects 1,400 in total. The graph shows the possible combinations of the number of adult tickets sold and the number of student tickets sold. So, we want to know, when 0 adult tickets are sold, how many student tickets are sold? Before I do anything, let's take a look at the graph. I can see my x-axis is the adult tickets sold. And on my y-axis, we have the student tickets sold. So, when 0 adult tickets are sold, how many student tickets are sold? So we're going to go to the adult tickets. It's on the x-axis. We're going to go to 0. And now we're going to go up until we could find how many students tickets are sold. When does it hit that line? Right above here. So when 0 adult tickets are sold, 200 student tickets are sold. Now it puts 200 student ticks. Okay. When 0 students tickets are sold, how many adult tickets are sold? Now we're going to do the opposite. Now we're going to look at the y-axis, and we're looking for 0 students, which would be right here. And then we're going to go across until we find how many adult tickets, where did we hit that line, and that's right over here. When 0 tickets or student tickets are sold, they sold 140 adult tickets. Okay. If 40 adult tickets if 40 adults attend, approximately how many students attends? So if 40 adults are over here, we're going to grow up, 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 approximately, because it's not directly on there. So we're going to say approximately 140 students. Now, if 60 students attend, approximately how many adults attend? If 60 students attend, then approximately 100. Approximately, this little squiggly line means approximately. Approximately 100 students attend. Sorry, 100 adults attend. Now the last one, true or false? This one's a little trickier. If 40 fewer adults go, there will be room for approximately 60 more children. So how do we figure this out? A good way to think about this, let's see what's the maximum amount of adults that can go. If we take a look here, the maximum amount of adults that can go if absolutely no students go is 140. Now, if 40 less adults go, so 140 minus 40, that means if 40 less goes, then we could say 100 adults go. If 100 adults go, we look over here, then approximately, right over here, 60 students can go. So, true or false? Approximately 60 more students can go. So this is true. Okay, number 4. A bakery sells custom cakes with a base size of 8 inches. An 8-inch cake with no additional decorations costs $20. Each additional inch increases the cost by 50 cents, and each decorative topping adds $1.25. Write an equation that represents the cost of a custom cake. Be sure to specify what the variables represent. So we want to write an equation and we want to specify what the variables represent. Now, there is actually some extra numbers in here that might confuse us. So let's take a look and read that question one more time. And what we're going to focus on is what costs money, because we're looking for the cost of a custom cake. So a bakery sells custom cakes with a base size of 8 inches. 8 inches isn't money, so we're going to keep going. An 8-inch cake with no additional decorations cost $20. Okay, we have $20 is for the cake. Just the cake with nothing else on it. Each additional inch increases the cost by 50 cents. Okay, so that's 50 cents for each inch that is added. And each decorative topping adds $1.25. So for each additional topping is another $1.25. So we want to create an equation. I'm going to start with T because we want to create an equation that represents the cost of a custom cake. I'm going to say on the right side, because we have to specify what the variable represents, T is the cost of the cake or a custom cake. The cost of a custom cake. So T equals, no matter what I do with this cake, if I buy just one of them, I'm always going to pay $20, no matter what. Plus, let's say I did one additional inch to this cake. If I did one additional inch, it will be 50 cents more. But if I do two additional inches, that's going to be 2 times 50 cents. It's going to be $1 more. If I do 3 additional inches, it'll be 3 times 50 cents. If I do 4, it'll be 4 times 50 cents. Okay. Now, let's go back to our original. Let's say we have the base of $20. We have the 50 cents. And now I'm going to add a decorative topping. That costs $1.25. Just for one. But if I did 2, it would cost $1.25 times 2 toppings, which we have here. If I did 3, 3 toppings. If I did 4, it would be times 4. So when we're creating the equations, we want to think about what value is always changing. If we look at this, the 50 cents is always the same, but the amount of inches you add will multiply it. So we're going to create a variable for that. T equals that base fee of 20, we're always going to play that 20, plus the 50 cents, let's say, times P. And P will represent, P is each additional inch, plus 1.25. Now, this is always changing for each decorative topping. Let's say D, where D is each decorative topping. And this is our equation right here. The total cost of a cake is $20 plus 50 cents times the amount of additional inches of the cake plus $1.25 times each number of decorative topping. And so this gives you 1 point, and the other point is clarifying what all your variables represent. You could have used different variables as long as you stated what each represents. Something similar to this would be the correct answer. Moving on to number 5. Consider this system of equations. Label each graph and the solution. So I'm going to show you guys 2 different ways we can graph. Let's start with the first one. We have y equals negative 1/2 x plus 3.5. First of all, I'm going to start with saying I would rather this 3.5 be in decimal form. So if I bring this down, and I'm going to convert it to decimal, 3.5 is the same as saying 3.5. or 3 plus 1 divided by 2, because you do 1 divided by 2 for that fraction, and it's 0.5, so 3.5, plus 1 half x is equal to y. Now, if you guys recognize this, this here is in slope intercept form. And that is y equals, and I'll put an equal sign there. This is y equals mx plus b, where m represents our slope and b is our y-intercept. So if I take a look here, our slope is y is 1 half. Oh wait, I'm missing a sign here. This is negative 1 half. Our slope is negative 1 half, and our y-intercept is 3.5. So when we have slope-intercept form we want to graph, we're going to start with the y-intercept. This is 3.5. You're going to go to the y-axis, and you're going to start on 3.5. So that's 0, 3.5. That's be right between 3 and 4. Right there. We're going to do right in between. I'll raise up a little bit higher. There we go. The next thing you're going to do is you're going to look at your slope. Slope is another way to look at it is rise over run. And if I look at this carefully, my numerator is negative 1. Negative 1 means we're going to go, and we're going to rise, but instead of going up, we're going to go down. Over, our run is positive 2, so we're going to go to the right. Start at your y-intercept, and you're going to go down 1 whole unit and 2 to the right. That's another point. Go down 1 whole unit and 2 to the right. That's another point. Go down 1 whole unit and 2 to the right. That's another point. And we can do that. Let's do this one more time. Be careful down here because the numbers are here, but the graph is still here as well. Go down 1 more unit and 2 to the right. Once you have enough points that you can take a straight edge, you can take a little ruler. Will this work for me? No, this ruler isn't great. We're going to put this ruler away. But you can take a straight edge, line up. It could be a ruler, it could be your ID card. Line up all the dots, and you're going to draw a straight line from one end to the graph to the other. Notice I'm going all the way to the end. And then I'm going to add a little arrow. And then I go all the way to the other way to the end. Make sure everything's lined up. And another arrow. And they say to make sure you label each graph, meaning you're going to put the equation next to the line. Y equals negative 1 half x plus 3.5. The next thing is to graph the second equation. Now, what you could do is you could turn this into slope-intercept form. It's in standard form. We have 2x plus 3y equals 14. This is in standard form. You can convert it to slope-intercept form, and to do that, you have to get y by itself. So you just subtract 2x to both sides, then divide by 3. But I'm going to show you guys the intercept way. When you're in when you're in standard form, you can say x equals 0. And this here is going to help us find the y-intercept. Let me do this in a different color. X equals 0, and we're going to find the y-intercept. At the y-intercept, the x is always 0. So we're going to plug in. We're going to go all the way over here. We're going to say, what if x is 0? And we're going to say 2 instead of x, 2 times 0 plus 3y equals 14. By the way, I just realized this equation is minus 3y, not plus 3y. Minus 3y equals 14. Well, 2 times 0 cancels out. That's 0. And we're left with negative 3y is equal to 14. Then we can divide negative 3 to both sides. And you'll get y is equal to negative 4.66666, or we could round this to y equals to negative 4.67. And we can make an approximate guess. Oh, so the coordinate of this is going to be our x is 0, and our y is negative 4.67. And we can take an approximate guess that's going to be between negative 4 and 5 on the y-axis. This is the y-intercept. A little closer to negative 5. And it's right there. Let me make this line blue. So right, roll 2 down. Right about here. Good. Now, we have the x-intercept. We need one more point to graph it. What we could do is we're going to now find the y-intercept. To find the, we found the y-intercept. We need to find the x-intercept. At the x-intercept, y equals 0. So now we're going to plug into the equation, the same equation, 2 times x minus 3 times 0, because y is 0, equals 14. This time, negative 3 times 0 cancels out. We're left with 2x equals 14. We divide 2 to both sides. X is equal to 7. So the coordinate point for this one, x is 7, y is 0. And that's going to be, we go to the origin, go over to 7, 0, put a point right there. And now we have at least 2 points. We can take a straight edge, take a ruler, and draw a line all from end to end that connects the dots. Right there. And then I can go in the other direction. Right there. Give me some arrows. And don't forget to label the graph. So this is 2x minus 3y equals 14. And it says, solve the system by graphing, label the solution. So if I remember, I have a system of equations that's 2 or more equations, and they're both graphed here. Where they are graphed, the point of intersection is our solution. The solution is 7, 0. X is 7, y is 0. That's where the points intersect. That is the solution. Okay, guys, we're moving on to the next part. That's number 6. Solve the system without graphing. Show your reasoning. So when you solve a system without graphing, that means you're either doing the substitution method or the elimination method. This is also called solving it algebraically. What we're going to do is we're going to take a look at one of these equations. We'll start with substitution. And we kind of want to make it so that a variable is by itself. So what we could do here is, one thing we could do is we can either get y by itself or x by itself. I think getting x by itself might be a little easier, so all we have to do is add 6 to both sides. So let's add 6 to both sides. And now we're left with 3y plus 6 equals x, or you can rewrite it as x equals 3y plus 6. Now, we have a variable by itself. Our x is by itself. We're going to now substitute that into the second equation. So anywhere we see x, let's rewrite it first. 2x plus 5y equals 12. And anywhere we see an x, we're going to substitute it with 3y plus 6. 2 times, instead of x, 3y plus 6, close those parentheses, plus 5y equals 12. Now we only have one variable, that is y, and we're just going to simplify and combine the equations. So 2 times 3y, that is 6y. 2 times 6 is plus 12. Bring down positive 5y equals 12. Now we can combine our like terms. We have 6y, we have positive 5y. They both have y, so they're like terms. And we're left with 11y plus 12 equals 12. Now all we have to do is solve for y. So we can subtract 12 to both sides to get y by itself. We're left with 11y equals 12 minus 12 is 0. Now we can solve for y by dividing 11 to both sides, and 0 divided by 11 is 0, so y equals 0. We have the solution for y. But now we still need to find the solution for x. What you're going to do is we found a piece of the puzzle. We know what y is, so we can now plug this back in to the original, or one of the original equations, and solve for x. So let's do the first equation. We know that y is 0. We're going to go all the way up here. We're going to plug it back into the first equation. So 3y equals x minus 6. We know that y is 0, so 3 times 0 equals x minus 6. 3 times 0 is 0, so 0 equals x minus 6. To get x by itself, we're going to add 6 to both sides. X is equal to 6, or 6 is equal to x. So the solution is x is 6, y is 0. The solution is 6, comma 0. So this is if you use the substitution method. Let's take a look at the elimination method. So elimination method works when you have both equations in standard form, or you're able to line up all the variables and constants with each other. If I look at this, the second equation is in standard form, but the first one is not. We have to get x and y on the left side and the constant on the right. So you have to first rewrite the equation so we can line them up. So to rewrite the equation, we have to get x to the left side. So what we're going to do is we're going to subtract x to both sides. We have 3y minus x. We cannot combine them. They are not like terms. Equals negative 6. And if I look at the other equation, actually x is before y, so we're going to flip it around. We're going to start with this negative x over here, say negative x, and then this is a positive 3y, so we're going to say plus 3y equals negative 6. Awesome. We now have two equations that we can line up. So let's do 2x plus 5y equals 12. Now we're going to line up the other equation that we just rewrote underneath it. Negative x plus 3y equals negative 6. Okay, now we're going to combine, oh, wait, can we combine them? If we combine these two equations, will anything cancel out? We have 2x minus x. That's going to give us positive x. 5y plus 3, which is 8y. None of the variables canceled out. So we want to multiply one of the equations. Let's see if we eliminate x. Can I multiply anything times 2 to give us a negative 1? Nope. What about if I multiply something to this to give us a 2? If I multiply the second equation, and remember, we want one of them to be positive, one of them to be negative. If I multiply the second equation by 2, this negative x will become negative 2x. So now the new equation, if we multiply the whole thing by 2, 2 times negative x is negative 2x. 2 times positive 3y is plus 6y. And um, 2 times negative 6 is negative 12. Now, we're going to combine the other equation on top. We're going to re-put the other equation on top of it and line it up. 2x plus 5y equals positive 12. Now we have coefficients that are matching and they're opposite signs, so if we combine them, they should eliminate. 2x combined with negative 2x is the same as saying 2x minus 2x. These will cancel out. 5y plus 6y is 11y, and 12 minus 12 is 0. Now we have something it would look like over here. You would divide 11 to both sides. Y equals 0 divided by 11 is 0. Y equals 0. We have something very similar to what we had over here. And then you do the second part of it, which is to use y equals 0 to find x. We can, you know what, for the sake of it, since we've done one, we did this equation, let's do the other one. So if I plug 2x plus 3y equals 12, and we know that y is 0, let's see what happens if we try to find x. 2x plus 3 times y, but instead of y, 3 times 0. We're going to plug that in, equals 12. Well, 3 times 0 cancels out, that's your 0. We're left with 2x equals 12. To solve for x, we divide by 2 to both sides. X is equal to 6. We have x equals 6, y equals 0, and as we said earlier in the substitution method, the elimination method has the same answer. The solution is 6, 0. There is an example of both methods. There still could have been some variation. You could have solved for, or you could have tried to eliminate y, but you would have had to multiply both equations. Or you might have used the other equation to solve for it. Okay, guys, we're moving on to the next question. The following system, or use the following system to respond to the questions. X plus y equals 16, 2x plus 4y equals 8. If we double each side of the second equation, we have 4x plus 8y equals 16. Explain why the same pair that is the solution to the system is also a solution to the new equation. If needed, you can support your explanation with hanger diagrams or by inventing a situation that creates that the equations represent. So let's talk about it. If we double this, we're saying that every value here is doubled. And when we talked about systems, we had some examples in the past where we talked about the calculators and the measuring tape. And when you add those together, the new equation was also true. So if they had bought 8 calculators for the first time and 8 measuring tapes, and they paid $40, but then they bought 2 more calculators and 6 more measuring tapes and paid $60, if they combined those two equations, that new equation would have also been true. That's the one we talked about in class. Let's talk about this one here. So first, the statement is if you double an equation in a system, the new equation is true because it's balanced. You multiply 2 to one side, and you also multiply 2 to the other side. Everything was multiplied by 2. We can use a hanger diagram to actually show this. So for example, if we have to balance, if you guys remember the hanger diagrams, what you put on one side, if you have it balanced on the other side, the hanger diagram should remain balanced. On this second equation, we have two x's, x and x, and we have four y's. 1y, 2y, 3y, 4y's. On the right side, we have 8 units. So 2x and 4y's is equal to 8 units. Now, what happens if we double it? Remember, this is like a scale. So if I double everything on this side, we'll have 4 x's, we'll have 8 y's, 2, 3, 4, 5, 6, 7, 8. And in order to keep this scale balanced, everything on the right side would also have to double. So this would become 8 units times 2, which would be 16 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is, oh, this is balanced. Okay, let's talk about number 8. Number 8 is a long one, but we're going to talk about a way that we can get rid of these fractions so we can deal with it. Determine the integer values of k such that 3 over 5k times 1/2 k minus 4 is equal to 1/4 times 5 over 3k plus 3. What we want to do is we want to solve for k, so we're going to do this the same way as if we had just regular whole numbers here. We can distribute. Um, but before I continue, what I want to say is if you had multiple choice options here, something you could do is you can plug these in, you can even throw them in the calculator. And if you simplify this and simplify this by plugging in, let's say 10 for k, if both values are equal, that means that's the solution. But if you want to do it the long way, this is how it's done. Or this is one way. You could have done this many different ways to get to the solution. We're going to distribute 3/5 times 1/2 k. 3 times 1, we're going to multiply across. 3 times 1 is 3. Sorry, it's 3 times 1k, so 3k, over 5 times 2 is 10. Continue distributing. Remember, if you have a whole number or an integer, multiplying by a fraction, you can put that integer or whole number over 1. 3 times -4 is -12. 5 times 1 is 5, so -12 over 5 equals 1/4 times 5/3 k is 1 times 5 is 5, 4 times 3 is 12, and then we have that k. 1/4 times 3 is, we're going to put it over 1. 1 times 3 is 3, or positive 3, over 4 times 1 is 4, and this is our new simplified equation. But we can do more. I don't like fractions, so something I always like to try to do is get rid of the fractions as soon as I can. But before we can do that, what we want to do is we want to make all the denominators the same. So we want to find a multiple that these four numbers have in common. If you're not sure, what you could do is you can list all four of them down. We have 4, 5, 10, and 12. And you want to see what number do they all have a multiple of that is in common. Well, let's do 4, 12, 4, 8, 12, 16, 20. I'm going to keep going. I'm going to skip ahead because I know what value we're looking for. But let's say we have 52, 56, 60, and 64. But you keep going until you can find a common value. Over here we have 5, 10, 15, 20. We'll skip ahead a bit. We'll go to 55, 50, 60, 65. Then we have 10, 20, 30, 40, 50, 60. And then we have 12, 24, 36, 48, 60, 72. If I look at them, they all have 60 in common. Or if you could just figure out what value they all have in common, you can also just multiply them. So what I want to do is I want to make all those denominators 60. 3 times 6, 6 times 10 will give us 60. What you do to the denominator, you do to the numerator. 5 times 12 will give us 60. What you do to the denominator, you do to the numerator. 12 times 5 will give us 60. You do it to both. And 4 times 15 will give us 60. And now we just have to simplify it. So all the new denominators are now 60. So let's write our 4 fractions. We have 60, 60, 60, and 60. Now let's work out the numerators. 6 times 3k, that is 18k. Negative 12 times 12 is negative 144. 5 times 5k is 25k. Oh, I forgot my equal sign. And 15 times 3 is 45. And it's positive, so it's plus 45. Now, we have all the denominators the same, and I love this. Why? Because we can now eliminate them. Remember, denominators are in a fraction. Fractions mean division. So if we do the inverse operation of division and multiply the whole equation by 60, that will cancel out every single denominator. Now we're left with 18k minus 144 equals 25k plus 45. All we have to do now is get all the constants on one side, all the variable terms on the other side, and solve for k. So we can add 144 to both sides. If I'm correct, that is 189. Bring down everything else. 25k equals 18k. Now we want to solve for k. Oh no, wait, not yet. Well, we're still solving for k. We want to get them all on the same side. 25k subtracted from both sides to get all of the k's on the left side. 18k minus 25k is negative 7k equals 189. Now to solve for k, we divide negative 7 to both sides. K equals 189 divided by negative 7 is negative 27. The value of k is negative 27. If it was given to you in multiple choice, you could have plugged that in to check it from the beginning. And if you do want to check your work, you plug this back into the original equation. And if you get two values that are equal, then the equation, k is negative 27. Okay, guys, we're moving on to the last question. Now, this one is a little bit tricky, so definitely look at the structure of this so we can follow along. At Max's aquarium, the number of goldfish, which is G, I'm going to circle that and underline what it represents, the number of goldfish, is initially 8 less than 4 times the number of tropical fish, T. T is the number of tropical fish. If Max decides to add 4 more each, the ratio of tropical fish to goldfish will be 2/3, or 2/3. Write an equation or a system of equations that can be used to find the number of tropical fish and goldfish Max has in his aquarium. Okay, so we need a system, so that means we're looking for 2 or more equations. Let's start with the first one. If we look here, it says G is. Now, guys, the word is a common word that means equals. So G equals something. So G is 8 less. Well, when I think less, I'm thinking of subtraction. 4 times the number of tropical fish. Well, T is tropical fish. So 4 times T would be 4 times a tropical fish, and 8 less than that would be 4T minus 8. So our first equation is G equals 4T minus 8. Our second equation is a little trickier. It says if Max decides to add 4 more of each, the ratio of tropical fish to goldfish will be 2 to 3. So tropical fish we know is T. And it's a ratio, so T over G, which is goldfish, and we're going to add 4 to both of them. And the ratio of adding 4 to both is equal to 2 over 3. This is our second equation. Okay, could Max's aquarium initially have 12 tropical fish and 28 goldfish? Explain your reasoning. Now, in order for this to work, it has to work for both equations. So let's try one and let's see what happens. G equals 4T minus 8. We're saying the number of tropical fish is 12, so T should be 12, and goldfish is 28, so G should be 28. Is 28 equal to 4 times 12 minus 8? Well, 28 is equal to 4 times 12 is 48 minus 8. 28 is not equal to 48 minus 8, which is 40. Because this is not equal, this means there could not be 12 tropical fish and 28 goldfish. All right, guys, we're going to the last one. We are going to determine algebraically the number of tropical fish, the number of goldfish Max initially has in his aquarium. I'm going to do this using the substitution method. If you can figure how to do with the elimination method, that is another possibility. What we're going to do first, though, is we're going to simplify this equation so it's a little more easier to work with. If I have T plus 4 over G plus 4 equals 2/3, because I have two fractions that are equal to each other, what we could actually do here is we can cross multiply. So we can do 3, we're going to cross multiply, we're going to multiply 3 times T plus 4, and we're also going to multiply 2 times G plus 4. So 3 times T is 3T, 3 times 4 is plus 12, is equal to 2 times G is 2G, 2 times 4 is plus 4. Oh, I'm sorry, it's plus 8. Okay, now we're going to solve using substitution. If you remember the original, one of the original equations is G equals 4T minus 8. We can plug this in for anywhere we see G in the equation. So 3T plus 12 equals 2G plus 8. I'm going to replace this G with 4 minus 8. So 3T plus 12 equals 2 times 4T minus 8 plus 8. We have that over there. Now we're going to simplify. 2 times 4T is 8T. 2 times negative 8 is negative 16. 8. Oop. T times negative 16. Bring down everything else, plus 8 equals 3t plus 12. Now, simplify like terms. It's negative 16 plus 8 are like terms. This is, if you combine them, that is negative 8. Bring down the 8t equals 3t plus 12. Now we're just going to get all the constants together. Let's subtract 12 to both sides. 3t equals 8t minus 24. No, minus 20. Now we're going to get all of the t's together. Subtract 8t to both sides. 3t minus 8t, I'll bring it over here, is negative, sorry, 3t minus 8t is negative 5t equals negative 20. Now divide negative 5 to both sides. Negative 5 divided by negative 5. T is equal to negative 20 divided by negative 5 is positive 4. This is one of our values. To find the second value, what you do is you go all the way up, and we're going to substitute this value here into one of the original equations. I think g equals 14 minus 8 is going to be easier to work with, so we'll use this equation. G equals 4t minus 8. Wherever we see t, we're going to plug in a positive 4. G equals 4 times positive 4 minus 8. G equals 4 times 4 is 16 minus 8. G equals 16 minus 8 is 8. So G is equal to 8. The number of goldfish are 8, and the number, or is 8, number of tropical fish is 4. And this here is your final answer.